Hello learners, welcome to Physics Form 4. We are still on the topic of thin lenses. We want to wind up by looking at the human eye. Now, when we're starting this topic, we say that the eye is a good example of a lens that is naturally made by God, and then we have it there to enable us to see things. Now, we are going to look at the defects that we find, defects of vision. As you can see, personally, I have a defect with my eyes. And that's why I'm wearing lenses to enable me to see. There are two types of defects, and I want you to look at the way we write them. It will give you a hint of how to remember them. I'm going to divide the board into two. One side we have myopia, also known as short sightedness. Then we have the next one, hypermetropia, known as long sightedness. Now, just by the size of the word, that's the hint that I want to give you. The short one is a shorter word, short-sightedness. The hyper one, the big long name, is for long sightedness. And we define it this way. Myopia is the defect where the eye can only see near objects, but it cannot be able to focus properly on objects that are a bit far. When you come to the other side, this is a defect of the eye where the eye can only see objects, able to see objects that are far. But when you bring an object near, this person cannot see it clearly. Now, how do we solve this problem? I want to use some diagrams. Let me start with how this myopic person sees near objects, how he sees far objects that are far, and how we can correct that problem. So, when this myopic person is looking at objects that are near him or her, this is what happens. That's the eye. If the object is too near, maybe here, then he is able to see it because his converging lens can be able to focus that clearly, and he sees the image in the retina. If the object is too far, this is what happens. If the light is coming from very far away, then this person cannot be able to focus, and the focusing will be in front of the retina. And here he cannot see it because it is in front of his retina. But we can correct that using a concave lens, so that when the light comes, first of all, before it enters his eye, it is going to be spread a little bit. Remember, the concave is to diverge. So it will be diverged a little bit. And now his eye can be able to focus that as a clear image. So the correction, we do it by using a diverging lens. That's how we correct myopia. So that we can first spread the rays a little bit, and it enables him to focus in the retina and suffer this problem that we are saying. When the objects are too far, he focuses near in front of the retina. We come to the other side. How does a hypermetropia person see near objects? Objects that are far, and how do we correct that problem? So let me start with objects that are too near. If this is the eye, a hypermetropia person, if the object is too near, then what happens? His eye focuses the image behind the retina. So this is what will happen. The image now comes behind the retina. That's the problem there. So he is not able to see this object clearly. Next we have, in case the image is far, this is where now he or she is perfect in. This one, the far one, it comes perfectly into his or her retina. So this one can see far objects clearly. How do we correct this? If the object is too near, assuming the object is here and this is the eye, we can put a convex or converging mirror here so that these rays that are appearing to be spread out can be brought a little bit near to somewhere here so that they seem as if they are a bit spread, a little bit spread. So it's like we are creating a new position of this object. So it's like it's a bit far, a little bit, so that you stop seeing it too near. We make as if it's a little bit far at this position, and now his eyes can be able to convert that into the retina, and he's able to see the image properly. So how do we correct hypermetropia? We correct by using a converging lens. Now, what causes myopia? What are some of the causes of myopia? Causes number one, we say this person has a short focal length. That is one of the problem. Number two, this person has a long eyeball. That can also cause that. The opposite is true for long-sighted people. We have them with long focal length, and we also have them with short eyeballs. Now, myself, I'm suffering from one of these, and that's why I have my lens. I'm said to have a long eyeball, or what we call a short focal length. So you can look at that and you can see where I'm placed in these two defects. Next, we look at what are some of the similarities between a human eye and what we call a camera. Because the designer, the person who designed a camera, had some little knowledge on how the human eye works. So similarities between a camera, like the one that we are recording with, versus the eye. So we start by looking at the similarities, and then later we shall look at the differences as we wind up. So the similarities, number one, we say that the eye has what we call a crystalline lens, convex lens, and at the same time, the camera has a convex lens. That is one similarity. Number two, so this is natural, this is man-made. Number two, the human eye has a choroid layer, which is black, and on this other side we say a camera's box is painted black, or it is dark inside there. Another similarity, number three, we say that the eye has a retina. The eye has a retina that receives the images. This other side we have, for the camera, it has light sensitive film that receive the image. So both of them, they have somewhere where the image is received. Number four, we say that there is the iris. The eye has the iris that controls the amount of light. On the other side, we say that the camera has what we call a diaphragm. It has a diaphragm to control the amount of light. However, there are some differences between the two. One of the differences between a camera and an eye is that when you look at the camera, we say that the focal length of a camera is fixed. The camera has a fixed focal length, while we say that the eye has a variable focal length. the focal length. That is one of the difference between the two. Number two, we look at the camera, especially those that can zoom. For example, the phone camera that can be able to zoom has variable image distance, while the eye has a fixed image distance. Finally, the last difference is that in the camera, one photo can be taken at a time, while for the eye, we have continuous. The eye is constantly recording images into our retina. But remember, we are talking of very old cameras. These days we have advanced ones that can overcome all this. But long time ago, the cameras could only take one photo at a time. That brings us to the end of the topic. These are some of the basics that I wanted you to have, especially for this first topic in Form 4. We shall be looking at more later and better things in the Form 4 work. So thank you very much and have a blessed time.